Yo, what is up, everybody? Welcome to today's explainer. We are skipping all that textbook fluff and taking this straight to the streets. Right now, in the absolute underworld of computer memory, there is a massive turf war going on. We've got two heavyweight mafias going head-to-head for total control, array and linked list. So, array versus linked list, asli boss gone. Who is the real boss? Let's get right into it.
Look, jab data handle karna ho to speed chahiye ya flexibility. When you're managing your data out there on the streets, you gotta ask yourself one brutal question. What do you actually need? Do you want raw, blazing fast speed, or do you need the flexibility to adapt when things go sideways? You literally cannot have both. It is the ultimate trade-off, and your answer dictates exactly which crew you're gonna hire.
All right, ding ding, round one. Let me introduce you to Array, the disciplined boss.
So Array is that heavyweight boss who buys up an entire solid block of real estate all at once. It stores elements in contiguous memory locations. Basically, everyone in the crew stands shoulder to shoulder in one straight line. But listen, here's the catch. Once that territory size is fixed, it does not change, period. No exceptions, no new recruits unless you buy a completely new block. But the payoff for all this strict discipline, you get direct, blazing fast access using indexes.
Moving on to round two. Meet the rival. Linked list, the flexible jugad.
Now, linked to list? This guy doesn't care about strict discipline. It survives purely on street smarts and extreme adaptability. It literally scatters its crew, the nodes, anywhere and everywhere in the memory city. So how do they communicate if they aren't together, right? Pointers. Every single guy has a direct phone line to the next guy in the chain. This dynamic memory allocation means the crew's size can change instantly at runtime. Need to pull new people into the operation or kick them out? Boom, it happens in a flash.
All right, enough talk. It's time for the brawl. Let's look at the head-to-head stats.
First up, we gotta talk about memory layout. Array runs entirely on contiguous memory. It locks down one solid city block where everyone is side by side. You always know exactly where everyone sleeps. Linked list, on the other hand, runs on non-contiguous memory. Its crew is completely scattered across different hideouts all over town, and they are held together only by those pointer connections.
Next up is size, and man, this is a massive trade-off. Array has a strictly fixed size. Once that real estate is bought, you cannot add a single inch to it. Linked list, though? It plays a purely dynamic game. It can instantly grow or shrink based exactly on what the situation demands out there on the streets.
But here is where Array pulls out its absolute biggest weapon, speed. We're talking constant time access, O of 1. Because the territory is contiguous and those indexes are fixed, you know exactly where every single person is. If you need the 50th element, you don't go asking around. You just kick down the door and grab it. It is immediate, blazing fast access, zero waiting.
And this right here entirely exposes linked list's biggest weakness. It's stuck with O of n sequential access time. To find the 50th guy in a linked list, you can't just jump straight to his hideout. No way. You literally have to start at the first guy, ask for the second guy's location, find him, ask for the third. You have to traverse node by node by node. For raw access speed, linked list gets absolutely beat down. But hold up, when it comes to inserting or deleting someone from the crew, the tables turn completely. Array is incredibly slow here. Why? Because if you add someone in the middle, everybody else has to physically shift positions to make room. It's just way too much work. Linked list? Fast and lethal. Once you actually locate the node, you just break the pointer connection, link the new guy in, and you're done. No shifting required.
So what about the cost? Let's talk memory usage. Look, linked list gives you total flexibility, but it comes with a massive hidden tax. Every single node burns extra memory just to store those pointer connections. It takes actual resources to keep track of a scattered crew. Meanwhile, Array, it's a lean, mean machine. It uses significantly less memory overall because it only stores your actual data. No extra burner phones needed. Let's look at some deep tactical street intel real quick. If your data's sorted, Array lets you use binary search to just slice through information, while linked list is stuck doing a painfully slow linear search. What about cache performance? Array absolutely dominates because that contiguous storage means high cache hits. And honestly, Array's implementation is beautifully simple. Whereas managing all those scattered pointers in a linked list, that can quickly turn into a highly complex mission.
So, the verdict, Quisco Kab Bulayan. Who do you call and when?
Look, you choose Array when you already know your exact territory size in advance.
If your data is static, we're talking complex matrices or lookup tables, and you demand that blazing fast, direct, random access, you call in the array. Nobody beats this disciplined boss on its home turf.
On the flip side, you choose linked list when the streets get chaotic. If your data size is dynamically changing on the fly and you are dealing with frequent, heavy-duty insertions and deletions, like if you're managing real-time playlists, active queues, or browser history, this highly adaptable boss is the absolute best one for the job.
The game is clear, guys. One rules with strict discipline and raw speed, while the other operates with dynamic, scattered flexibility. There is no ultimate boss in the data structure underworld, just the right weapon for the right problem. Tomorrow next project is Zimedari Kiski, array or linked list. Who is taking charge of your next project? Make your choice, own the turf, and keep crushing that code. I'll catch you in the next explainer.